Sissy Lundeby at LeanTech. In this video I'm going to show you two examples of how you can use Statistical Process Control, SPC. SPC is a tool to separate between normal and special variation, and you use control chart with control limits in order to decide what's normal variation and what's special variation. And I'm going to show you later control charts and how it works. The first case that I'm going to show you is this test. It's a medical test for diabetes. And as you can see, this test has a label, just like a lot of other products. And what is special about this label is that it's just enough space on the lid for this label. If you look at this test, you see that the lid, the edge of the lid is here, and the label is almost the same size as the available space on the lid. This means that the machine that is going to place the label needs to be both accurate and precise in order to prevent bad parts. If you have a machine that needs to be both precise and accurate, like this one, you could risk having a lot of scrap. And if this is the case, usually operators and technicians, they want to do a really good job, so they start adjusting the machine. And does it really help? Not necessarily, because if your problem is precision, then you can't adjust out of the problem. If you have a problem with accuracy, then you can adjust the machine so that it can hit the target better. But all machines have a certain amount of normal variation, and you can't adjust away from the precision of the machine. So in the cases where you have a lot of scrap and too much normal variation, you have to consider other options. In this case, maybe you could shrink the label to make it fit better on the lid, or maybe you can make the lid bigger to make a more robust process. Else you have to accept that this machine produces a certain amount of scrap and then build it into your cost calculation so that you take the right price for your product. And if you're not happy with the scrap of this machine, then you might want to invest in a new machine. And I recommend you, when you're investing in new machines, that you consider the normal variation of the different machine that you're going to choose between. And choose the one with the lowest normal variation, the most precise machine, because that's going to make a more robust process for you in the long term. So good luck with the new investments, and hopefully you will consider using Statistical Process Control the next time you're investing in new machines. The second example that I'm going to show you is about milk. I have some liters of milk here, and I'm going to weight the milk and figure out the normal variation of the machine that has tapped the milk. So for this example, I will say that all of the milk that I have in the refrigerator and on the table, they are tapped on the same machine, and then I will show you how you can calculate the normal variation of this machine. So what I'm doing is that I have a weight. I have to reset it, and then one by one I will weight the milk and I will notice the result. And I'm going to show you now how you're going to calculate the normal variation of this machine. This is a control chart for skimmed milk, tapped machine number 1. You can see I have weighed milk for several days. You have the date on the x-axis and you have the weight on the y-axis. And the average weight is 1064.6 grams, and you have a variation of plus minus 1.5 gram. This is based on the control limits. You can see the control limits are the red lines. And the control limits represent the expected normal variation on the short term. They are calculated based on the range. The range is the difference between two following values. I haven't shown the range chart here because I wanted to simplify it, but the range chart shows the difference between two following values, and based on this range chart, the upper and lower control limits is calculated. So what these control limits tell you is what to expect from the process based on the short-term variation. This control chart shows skimmed milk tapped at machine number 2, and as you can see, the average is 1064.4 grams, and you have an expected normal variation of plus minus 2.5 grams. For machine number 1, the variation was plus minus 1.5 grams. So machine number 2 has a greater variation compared to machine number 1. It's the same product that is tapped on both machines. This means that the machine number 1 is more precise than machine number 2. This is a control chart of buttermilk tapped at machine number 1. The average is 1033 grams, and you have an expected normal variation of plus minus 7.4 grams. If we look back at skimmed milk tapped at machine number 1, the variation was plus minus 1.5 gram. So you have a much greater variation for buttermilk compared to skimmed milk. The reason for this is the physical properties of the product. Buttermilk is thicker and can contain some air bubbles. And the dosing of machine number 1 is based on volume, not weight. And because of this, air bubbles can disturb the measurement and make machine 1 less precise for buttermilk compared to skimmed milk. You can use statistical process control and control chart for your own process and in order to compare different machines or different processes and look at the expected normal variation. And then you can start questioning why there are differences. You can use statistical process control for maintenance purposes. If you have a machine that is starting to wear, you will usually see that the machine is less precise. So you can have some warnings when the control limits are increasing, get wider, because this can be due to wear. You can also use statistical process control and control chart if you want to check the effect of an improvement. If you did a change to your process and you want to see the effect, you can calculate the control limits before the change and after the change, and you can find how much did the change affect the process.